Hi there, everybody. Welcome to Building Science Digest. I'm your host, Christian Kennedy. And today's guest, we have Remi Goulet, who is the Director of Building Science for Saint-Gobain North America. Remi, welcome. How are you doing?
Good. Thank you very much. Thank you for having me, Christian.
I can't wait. We're going to talk about building fire safety today, which is a science. And to give our audience a brief kind of rundown of why you're the man to talk about fire and building fire and the safety behind it, why don't you let us know what your history is? I think it's been 12 years, right, that you've been with the company.
Absolutely.
But give us a quick rundown.
My background is in heat and mass transfer, which is very key to building science, right? A lot of building science relates to the movement of heat and the movement of moisture, through assemblies and in buildings. So this is when I learned at school, and I joined Saint-Gobain 12 years ago in central R&D, supporting all our businesses, essentially, construction products or non-construction products. So I stayed in this department for 9 years, and actually I became the building science director for Saint-Gobain North America.
Okay.
When we created a formal building science organization in Saint-Gobain, North America, actually in September 2022.
That's incredible.
So we've been having this formal organization. We're supporting all our product lines across US and Canada, but we are not really focused at the product level. This is really, a system thinking type of approach. Yeah.
And I think that right there is probably one of the bigger takeaways with all of building science, but really most importantly with fire and the building codes is that should be more focused on systems rather than individual products. So building fire safety, where do we start? What is the number one priority? What is the reason behind the changes in the industry and maybe the larger focus?
Absolutely. I think it's important to start with, the statistics related to fire in buildings. So actually, if you have a look at the numbers that are rolled up by the National Fire Protection Association, we know that in 2023, there were like 470,000 fires in our own buildings, right? Yeah. That led to like over 3,000 casualties. So and what's important to see as well is that like a third of the reported fires in the US are fires in our own buildings, or what we call structural fires.
Okay. So it's the structural fires are a third, and that the other 2/3
would be wildfires, vehicle fires, or like trash can, catching fire. Or outside storage, right?
Right.
Yeah.
Interesting. And the one takeaway that you just mentioned, where it's a third, or the structures themselves, but it's technically over 2/3. It's over 80% of actual casualties, and I think that's just something. That's why this topic has become such a hot topic. Excuse me. And why it's important to really take note of what changes we can do from a structural standpoint, but again, not being product focused.
Exactly.
What can you tell us about not only the wildfires and residential, but and how it plays into the commercial side of things as well?
I think there are two things to consider, right? Is that essentially 70% of the structural fires occur in one or two family dwellings.
Oh, sure.
So those are, single family homes or, duplexes. So I would say that the bulk of the fire problem is more on the low-rise residential side.
Interesting.
There is an increased risk due to wildfires, right?
Sure.
Mostly on the single family and, low-rise residential side. Right now, we have more and more developments happening in Wildland-Urban Interface areas.
Sure.
So right now in the US, we have 44 million houses that are in Wildland-Urban Interface areas.
44 million houses that are in wildland and urban interfaces.
Yeah.
Okay.
And that is increasing. That goes unabated, right?
Yeah.
We are developing more and more in those areas. And another thing to consider is that wildfires are becoming a larger risk. So the number of wildfires across the US is not necessarily increasing in terms of numbers. In 2022, I think we have 70,000 wildfires that were reported.
Okay.
And if you have a look at the data over the past 40 years, that evolves between 40,000 to 100,000. But there is not a clear trend in terms of increase of the number of wildfires.
You're saying technically haven't really gone up
in terms of numbers.
In terms of sheer numbers,
exactly.
Yes. And we were talking before this, but they have gone up in regards to
the area
coverage
that is actually burned, right? So it's interesting to note that 40 years ago, wildfires were burning like 3 million acres of land, right? Trees, forest, and grassland, right? Now we are approaching 8 million. And even we had, like 10 million acres that burned like in 2015 and in 2020. Right?
Wow.
So that is dramatically increasing. And actually, if you have a look at the 10 years where we had the largest acreage burn, they all occurred after 2004, which is also the period when we recorded the highest temperatures nationwide.
Sure.
So there is a correlation between
the temperature rising,
temperature rise, right, and the extent of wildfires. So if you have a look at this, essentially, like more and more people are living in wildland-urban interface areas, so basically, near wildland, and the wildfires are increasing in terms of, extents, right?
Interesting.
And meaning that there is a larger risk for people's houses, right, in terms of exposure to wildfires.
Is there a way for the single family dwellings and the multifamily dwellings to protect themselves, protect from the potential spread of the wildfires to hit their homes?
In the U.S., we have what we call the Wildland-Urban Interface Code, which is essentially a building code that was developed that comes on top of the regular building code, right? But that was developed to really reduce the risk of house or building destruction due to wildfires. And essentially, we see that there is an increase of the adoption of that code across jurisdiction in the U.S. Some states have adopted that at the state level, but we also see counties or municipalities adopting it. And that adoption is increasing really because of the increase in awareness of the wildfire risk, right? That is actually increasing over time.
Right, and we've seen it, Is there something to be said about how the duplexes and the residential buildings are constructed? Can you speak more to that part from the residential side?
Absolutely. I think you're raising a good point there in terms of ignition-resistant homes, right? And I think even if we take a step back and we look at the code, this is really that Wildland-Urban Interface Code. This is really a holistic approach. So essentially, it touches on ignition resistance, so how the structure is built to limit the risk of ignition, but also it's very interesting because it touches on the water supply, how much water is available for fire suppression, fire extinguishing. Essentially, it also touches on what we call the defensible space, which is how your space outside your home should be organized from a vegetation standpoint to limit the amount of fuel that is available right next to your walls, right next to your structure. And it also touches on like emergency access, right? Can the firefighters access your home easily, right? But to your point, really also the bulk of the code focuses on ignition resistance. And there is, I think, one point it is important is that a lot of the fire propagation, the fire spread, right, from wildland to houses and then from houses to houses is due to embers. Generally, you have an accumulation of those embers, right, at the overhangs, right, in the soffit area of the house. And it means that this is really an area that should be protected from a fire standpoint. So generally, we would want, the overhang to be protected by, using non-combustible materials or materials that are very fire resistant.
Absolutely.
And also what we want is to not have any venting of the attic through the soffits.
Okay.
Because a lot of what's happening in terms of fire propagation is that burning embers, so embers are getting into the vents, getting into the attic, right? And then if you have combustible material in the attic, then this is how your house catches fire. So then the idea is really the Wildland-Urban Interface codes precludes venting of the attic through that overhang area, through the soffit, right? It requires that it be done, at the gables of the house, right? Not at the overhangs, essentially, which is a very, very important point.
And so essentially what the code is recommending, or not even recommending, is requiring is that you close those gaps off, right? You prohibit the embers
from getting
into the attic.
Exactly.
And that can minimize or mitigate the risk of, I guess, really a fire starting.
Exactly.
Interesting.
Or fire propagating from wildland to neighboring houses, and then from houses to houses, right? So that really limit the spread.
Is the Wildlife-Urban, is that code part of the 2/3 code that focuses on fire safety, that building fire safety? Is that all encompassing there, or is there an additional? Because we've talked about it before about how building code holistically 2/3 of it is focused on fire safety. is that included in that? Is the WUIC, is that included in that, or no? That's separate.
It's separate. Actually,
Okay.
if you have a look at the regular building code, right?
Yeah.
Then for that regular building code, if you omit like the structural provisions, then 2/3 of that content is focused on fire safety.
Okay.
And on top of that, you have the Wildland-Urban Interface code that is 100% focused on fire safety, right?
Okay.
In terms, with a holistic approach, right? In terms of defensible space, like we were talking about, right? Water supply, emergency access, and ignition resistance for the envelope. Yeah.
Interesting. So they're separate, but one is focused strictly on residential. Is that what I'm learning
Wildfire
here today?
is a bit more than residential, but I would say that this is mostly where it's being used, right? But actually, the Wildland-Urban Interface code covers more than just residential.
Just the residential. What is happening currently on the commercial side, commercial business side, that is elevating fire protection, fire safety, building fire safety?
I would say, yeah. So there are still, some casualties happening in commercial buildings, right? I mean, in non-residential space, or I would say, in multifamily residential, which generally falls under the commercial building code, or for truly commercial building, like commercial office spaces.
Sure.
There was like over 500 casualties, right, in 2023. So it's still an area where there are really some fires that are deadly. And when we think about the commercial space and how fire safety is handled, I think there are 3 areas, or there are multiple variables that control fire safety, but they can be organized in 3 categories. The first thing is like architectural design.
Yeah.
Right. You can organize your building, right, from a spatial organization and compartmentalization standpoint, so that you can really enable an easy egress, right, for the occupants in the event of a fire. So it's really about architectural design.
Okay.
Another part is about fire protection,
Yep.
and here you can look at active protection and passive protection, and we'll talk about those in a second. And the third piece is really public awareness, public education, right?
Okay.
People need to be aware, of we do fire drills for people to understand how to behave, right, when there is a fire. There is, a 911 awareness as well, right? Campaign. We need to make sure that people, know how to behave in the event of a fire in terms of, calling firefighters, as well as, evacuation plans, right? That need to be made clear, right, to occupants of buildings. So it's more like, public awareness. But if we go back to fire protection, so you can separate active fire protection, which are essentially measures that enable to suppress a fire.
Okay.
So think about, fire detection, fire alarms, sprinklers, right? As well as, fire hydrants and fire extinguishers, right? Those are all part of the active measures to suppress a fire.
Right.
So this is active fire protection, which is very strong actually in the US. And the other thing to think about is when you think about fire protection, it's passive fire protection, which is how the materials and the system that we use in building naturally offer some fire endurance, some resistance to fire, right? And I think this is really what us, a construction product manufacturer, we focus on, right, on the passive fire protection aspects.
Yeah, and I think majority of people focus on the active, right? They focus on the fire extinguishers, the fire alarms, right? They focus on that, or that's what maybe first comes to mind.
Yeah.
But what we're doing here, what you're focusing on, what you and your team focus on, is that passive, right? So
exactly.
What in particular about the passive fire protection has you and your team focused on?
In general, when it comes to passive fire protection, I think there are 2 concepts that are key. One concept is the concept of combustibility, right?
Right.
Are the materials that we are using going to burn and release some heat and smoke? Are they actually going to contribute to the growth of the fire, right?
Oh, are the materials you're using or potentially going to use in the building, are they going to add to the fire?
Exactly.
And that's that's not the goal.
I mean, it depends on the building type, right? But you would want, for, based on the level of risk, right? You would want to use, less combustible materials. Yeah.
You want to neutralize that.
Exactly. You don't want to add fuel to the fire, right?
There you go. You said it. That's
it.
Yeah. So we don't want to do that. So the materials that are being included in these projects, in the buildings, what can be done, or what are you working on? What is the team working on to minimize or neutralize that risk?
can I take the question a little bit differently?
Yeah, please.
I think
please. You are the expert.
I'm trying. So there is combustibility, right? And there is another aspect, which is the fire endurance, what we call the fire endurance of the systems that we use in buildings, right? So combustibility and fire endurance are very key in commercial buildings, and that's really also what is at the core, of the building code. And if you think about fire endurance, it's a measure of how a system is going to behave when exposed to a fire. And this is something that is measured. It's an experimental assessment, right?
Okay.
So if you take, let's say a partition wall, right?
Yeah, right.
That has to be fire resistant. So the way it would work is that we would build like a full-scale sample of that wall, and that has to be essentially 100 square feet in size, right? So a large wall sample. Sure, you essentially attach it to a furnace. You expose, one side to a flame, and you record, and you essentially identify how that structure is behaving. And you look at three things, right?
Okay.
Is it able to perform its structural function?
Okay.
Right, that's one thing. Does it stay like fire and smoke tight, right? Does fire and smoke, penetrate that wall or not? Or, does it stay
It will or
tight?
it won't, yeah. Okay.
Yeah.
Yeah.
And then the third thing is that, are we able to like limit the transmission of heat, right? From the area where there is the fire to the face that is unexposed, right?
Let's say that again. So limit the transfer of heat from the area that's on fire to
the face that is unexposed, right?
the face, so the other side of the wall.
Exactly.
Right. Okay. So the face that is unexposed. Interesting. So those are the three
Those are the three things we look at
that
when
you want to
we do
look
fire
at when you're
test
doing the testing.
for like a wall, right? It could be a floor ceiling assembly or other types of system, but those are generally the things that we are looking at. And essentially, based on the performance of that wall or that system, we're going to assign it like an hourly rating. We're going to say that wall is able to, as a fire resistance of 2 hours, meaning it's able to perform well, right, at the criteria, for 2 hours.
Okay.
Right? So it gives us an hourly rating.
So it can stand
for
up for 2 hours, essentially. Right?
Essentially, it can perform its function for 2 hours. It's structural function. It can stay, fire and smoke tight,
Yep.
and it can,
Protect
limit,
the other side of the wall.
protect the other side. And that's the part is very important because, if the unexposed face increases in temperature, then it can also ignite objects that are combustible on the other side, right?
Sure.
So that's why it's very important to limit that heat transfer as well, right? Yeah. So essentially, combustibility and fire resistance or fire endurance are key concepts.
So those are systems that you look at that systematically to ensure that a building is safe.
Yeah,
right?
And actually, combustibility is more of a product, like centric performance metric. But to your point, absolutely, for fire endurance and fire resistance, 100% this is a system level performance. And what's very interesting is that if you have a wall, or we're using the example of the wall, but if you have a wall that has a given level of fire resistance, then everything is prescribed, right? What type of screw you use, what should be the spacing between the screws, what is the size of the studs, and the gauge of the studs in terms of size. So everything is prescribed, right? So it's really an overall system performance, right, where all of the elements are prescribed. Right? The system performs at that level if it's using exactly that method of construction and those elements.
Oh, interesting.
So this is very
it's specific, and
extremely
yes,
specific.
and you can't waver.
You cannot.
Right. So you need to utilize or use what is recommended in order to maintain the structure of the products that are being used.
Exactly.
To ensure the safety of the people inside.
Exactly.
Is what we're going for here.
Yeah.
Interesting. What else? Because we talked about walls.
Yeah.
What can we do? Is there work to be done in the floors, in the ceilings? What kind of work can be done or is happening to increase the amount of protection or decrease the amount of potential risk for fires in buildings?
Yeah, I think absolutely. And what's very interesting is that all of that is regulated by the code, right? So essentially, the code is going to define different building types from building 1, building type 1 to building type 5. And it's going to be linked to, where you find combustible materials. And also it's related to the fire endurance of the structural system.
Fire endurance of the structural system.
Structural system could be, like walls in some cases.
Sure.
It could be columns, steel columns, steel beams, trusses, of course, floor ceiling assemblies, right? And the walls in some cases. So essentially, the code tells us, defines building types And those building types, whether a building, belongs to one type or another, is dependent on where you find the combustible materials and the level of fire resistance of the structural assembly, the structural system.
Okay.
I think this is very important because the number one thing in the code is like structural integrity, right? Okay. In the event of a fires, we need to make sure that the building remains, structurally sound and doesn't collapse, right? Yeah. We need to give enough time for the people in the building, right, to essentially live, right?
Yeah. So, Remi, we were discussing structural assembly protection, but specifically the steel protection part of it. Let's dive into that, and can you maybe provide some context or a story that brings that to life?
Absolutely. Based on the building type, you may need to protect your structural steel, right?
Sure.
What's interesting with steel is that steel is non-combustible, but steel in and of itself is not necessarily very fire resistant, meaning that if you leave steel exposed to a flame, its temperature is going to increase, and at one point it's going to soften.
Interesting.
Right? Its strength is going to reduce, which is going to put the building at risk, right, of structural failure.
Sure.
So based on the building type, you may need to actually protect your structural steel, protect your column, protect your beams, right? Really, and the way you do that, there are several technologies, but one technology that is used is that we spray a gypsum-based compound, right, directly at the surface of the steel, right, to protect it.
Interesting.
And that essentially spray-applied material provides some insulation level, right? It limits the temperature rise of the steel, right, of that structure, right, if exposed to a fire. So that's essentially one of the strategy there for structural steel protection.
And is the gypsum is that making direct contact with the steel structure itself?
Exactly, it is sprayed onto it, right?
Okay, so sprayed right on, and that helps increase the fire resistance. Thank you.
Yeah, exactly.
Interesting. Okay, so what other things are possible, or what other things are you working on with your team to increase the fire resistance for structural steel protection?
Thank you. So actually, something very interesting is that generally, like spray applied materials, right? Those what we call SFRM, spray applied fire resistant materials. They are applied to beam and columns, but you can also apply them to steel decks, right? Okay. In the steel and concrete buildings, you have a steel deck that is supported by beams. Those beams are supported by columns, right? Okay. So, and the underside of that steel deck can be sprayed. And I think there is something very interesting to discuss there because for floor assemblies, right? Generally, the fire resistance is governed by concrete. Concrete is a material that is cheap, has high compressive strength, that is reasonably ubiquitous as well because it provides intrinsically it provides fire resistance. But the big problem with concrete is that it is a high embodied carbon material.
Right, yeah, of course.
A lot of the structure, right, a lot of the embodied carbon that goes into a structure of a building is coming from concrete. So
really?
Yeah.
Oh, okay. Yeah,
so
I'm following.
So actually what we are looking at in our team, but also with our businesses, is how could we limit the amount of concrete that we use? And there is that very interesting idea that's really related to structural steel protection, right? So essentially, if you take, I'm gonna give you an example, but if you take like a 2-hour rated floor system, right? So this is a floor system that has to resist fire for 2 hours.
2 hours, right.
Then the way it is done right now is that you're gonna pour 4.5 inch of normal weight concrete onto your deck, right?
I'm envisioning that now, yeah.
Think about, that steel deck, right? You're gonna pour some concrete on top,
right?
And essentially the fire resistance for that floor assembly is coming from that volume of concrete.
Right, the concrete is providing the fire resistance.
The concrete is providing the fire resistance. What's interesting is that the concrete has two functions. It is structural, right? It enables the building to stand up, floor to basically to stand up and support, the gravity load.
Yeah.
But it also provides a fire resistance. And then what we can do is take a step back and think about, could we do that differently? Could we actually limit the function of concrete to structural and do the fire resistance using a spray applied material that we would apply to the underside of the deck? So we decouple those functions.
So rather than using concrete as the for two use cases, for structural and for fire resistance, it's rather focusing just on the structural part of it and going a different route to provide the fire resistance. And you said something interesting, and it was so 4.5 inches is what is typically used.
So if you would need, typically if you need a floor system that has a 2-hour
inches
rating,
of concrete
you would use
4.5
inch of concrete, right, topping on top of your deck.
Okay.
Right? But now if you decouple those two functions and you say, I am just designing my concrete so that it provides what I need for structural.
Okay.
And I do my fire resistance with a spray applied material that has spray on the underside of the deck,
sure.
right? So think about the deck, you have the spray applied material on the underside,
yeah.
and then you have the concrete that comes on top, right? So now what we were able to show is that for a commercial office space, to meet the structural requirements, you only need 2.5 inch of normal weight concrete.
Okay. Instead of the 4.5.
4.5 inches.
Okay. So we're going 4.5. We're going from 4.5 down to 2.5 because we're spraying on the underside of the deck.
Exactly. Because now the 2.5 inch of concrete are what's needed for the structural requirements. Yeah. And I'm taking out those 2 inches that were there really for fire protection, right, for fire resistance. So essentially I am taking out some concrete and I'm replacing it by spray applied material that literally has an insignificant embodied carbon compared to concrete.
And you're using less, and because you're using less, it's not emitting as much carbon. Is that?
I mean, the idea is that
on the right track.
Concrete is essentially it takes a lot of energy to produce cement, which is the key part, the binder in concrete. And essentially, the less you use, the less embodied carbon goes onto your building, right? So that's the idea, is that we go from 4.5 inch of concrete down to 2.5 inch. So we just meet the structural requirements, and we essentially meet the fire resistance requirements using this spray applied material that has virtually zero embodied carbon compared to concrete.
Right.
Yeah.
I know that we've got other stories out there. I think there is one that I want to focus on is the shaft wall story that you and I were talking about. Let's dive into that, and something that I think you've claimed is kind of like a massive innovation in your industry, in this industry.
Absolutely. I think there's been a very big innovation that happened in the 70s, and it really relates to compartmentalization, which is idea of subdividing a building into compartments, right? So that essentially, and those compartments, are limited by fire-rated assemblies, right? And the idea is that if you have the fire that originates in one compartment, then you would limit the risk of spread to another compartment, right? You would essentially delay the spread of fire because of that compartmentalization strategy. And that's a very important strategy because that's really something that enables people to leave the building in the event of a fire, right? Before the actual fire suppression measures come into action.
Okay,
right?
Interesting.
Shafts, so what we call shafts, those are vertical spaces that span multiple floors in a building. And generally those are used for, elevators, right? Moving up and down. They are used also for, exit stairways, right?
Okay.
So, and those structures are enclosed in fire-rated walls, right?
Oh, sure.
So you essentially, in a way, right?
They're emergency exit.
Yeah, exactly. You need essentially to make sure that your elevator functions, right, in case of a fire for the firefighters to come in.
Right.
And you need your exit stairway to also not be touched by the fire for people to get out. So those are essentially compartmentalized systems, right? Compartmentalized.
And those systems span multiple floors. So it's possible to have a compartmentalized room or floor or room within the floor, or have a system that spans multiple floors.
Yeah, exactly. And the shaft wall, generally they expand, if you think about, an exit stairway, like, the shaft wall would be enclosing that whole stairway, right? Across all the stores that it covers. So it's going to be essentially a wall that extends over multiple floors, right? Or a fire barrier that extends over multiple floors. And what's very interesting with those shaft walls, right, is that before the 70s, like, they were really either CMU blocks or cast-in-place concrete.
Okay.
And those are very heavy technologies. Also, it requires scaffolding, right?
Right, sure.
Because to essentially install those, you need to be, in the shaft, right? Essentially in the shaft, within the shaft, right? So it made those very long to install. They are very heavy, so they may also require to have stronger footing, stronger foundations for your building. But actually, what's very interesting is that in the 70s, the shaft wall system has really been disrupted by the gypsum industry.
Okay.
By the gypsum wallboard industry. Essentially, at that time, the industry invented like a type of stud that enables to install the wallboard without screws and just from one side. Meaning now you don't need any scaffolding. You can be directly on the building side, right? Outside of the shaft.
Yeah.
And you can install your shaft wall, meaning no scaffolding in the shaft. And no need for screws, for screwing the wallboard, so it goes way faster. So essentially, and gypsum is so much lighter than CMU or concrete. So essentially, you are replacing very heavy technology, long to install, by something that is very fast,
light, efficient, fast.
Exactly.
Yeah.
And essentially, what's very interesting is that there's the stud design that enabled that innovation. It's called a CH stud.
Okay.
So essentially, the wallboard is not screwed to the stud; it is friction fit. Right into the stud system. So think about it. You have a stud, right?
Yeah.
You're gonna put it in place. You're gonna friction fit your wallboard. It's a 2-foot wide wallboard into that stud.
Yeah.
Then you're gonna put another stud right next to it to keep it in place. And that stud also is gonna be like hosting the next gypsum wallboard. Right?
Oh, sure. Okay.
So essentially, you are just like building that structure, right? Like
you're almost building inside out. In a way where you're on the outside, you're on the exterior of the shaft, but you're building on top of it rather than being on the inside, the interior, and with scaffolding going up and then creating the barrier. Is that what we're talking about here?
Exactly. Yeah. You are not in the shaft. You are on the building side, or on the floor. Exactly right. And you can build that wall from that side without being in the shaft. And then you can do that by essentially stacking, like in alternance, stud and wallboard, right? And then that gives you that system that is very fast to install, very easy to install, that can be done from one side. And at that point, this truly disrupted that segment. So it has displaced like heavy technologies like CMU and concrete, cast-in-place concrete.
Right.
And then since then, gypsum wallboard shaft wall have been the dominating technology.
Huh.
So I think it's very interesting because in those two examples, you see that, in this one, you see that essentially, you don't look at the stud, you don't look at the stud only, you don't look at the wallboard only, you look at how those two come together, and you figure out a stud design that truly enables the use of wallboard, right? And that enables the use of a lighter and faster technology. Yep. So it's a system.
I was just going to say, right? Yeah. Instead of approaching it individually by room or individual structure, you're looking at the system or the building as a whole, and then focusing on everything, and not being very focused on the product, or the singular installation method, whatever the case may be.
Exactly.
Super interesting. I think what we've learned today, what you've taught me, is that there's more to building fire safety that meets the eye. It is an industry that is continuing to innovate.
Absolutely.
New designs, new methods, with, of course, obviously being the main goal, just keeping everybody safe.
Absolutely.
Right? It seems really silly at the high level, but ultimately it's a massive piece of the industry, a massive piece of building science. And I know personally, I'm very happy that you're at the helm of the building science team here at Saint-Gobain, North America.
Thank you, Christian. Happy to be there.
Remi, it's been a pleasure. I really appreciate our time today. Thank you all who are watching and listening online. You can get this podcast, Building Science Digest, anywhere you listen or view your podcasts. Thanks for watching.